Are you frustrated with your production orders? Would you like to be able to use the infinite schedule and then just have the machine turn off once you actually have the amount you need? Well, welcome to today's tutorial. Now, this tutorial was inspired by a comment I recently read here by 57A, saying trying to make a vending machine which drops a certain amount of food into a fridge so a duplicant can come by and pick it up. And this was summed up pretty good as by Hungry Hunter as well. It's way easier to make a fridge that has 1 or 2 meals ready, and then when the fridge is empty, a signal is given off. Well, what we're doing here is something that we've actually seen in other games like RimWorld and whatnot, and it's even something I've explored a couple times in the past, but not necessarily ever made a tutorial on or ever achieved that great of results. It is run until X. So essentially what we're going to do today is we're going to use the smart storage compactor in a couple different ways in order to build up a certain amount of inventory that we can then use for projects, and then once we reach a certain level, it'll go and refill itself. Now today we're going to be automating a rock granulator. However, as you can see, I've done it with Oxalite. I've also done it with a metal refinery. This could be applied to all sorts of things like farms and ranches, maybe even. If you get really creative, I don't know. You guys have to let me know if you guys have come up with some cool things down there. So this method is going to be running until X. So what X is in this case is a certain amount of stuff inside our storage compactor. So let's take a look at how the smart storage bin works. Now when you place it down, there's a couple different things that you can plug in. You can add power to this because it requires 60 watts. And what that 60 watts will give you the ability to do is send out an automation signal from it. However, if you don't plug any of that in, it just works like a normal storage bin. So in this case, what we're going to store inside of here is just some iron. So the duplicants should run on up there and start to fill that up. Yeah, there they go. So as you can see, we now have 1,000 kilograms of iron. This has a slider. We can bring this down to set the limit. So in this case, if we only want to have 1,000 kilograms of iron in here, then this would be full. If I plug this into our power circuit, you can now see that it has a little light. And what that light is telling us is the state of the storage bin. So you can see at this point, it's green, and that's because it's full. Now let's say we wanted to store, let's say 2,000 kilograms of refined iron, which is a good number to go with. You can now see it's now red. So red is going to disable the rock granulator here. So in order to make that work, what I want to use is the opposite of what this storage bin is. So when this is not full, this will be on. So therefore I'm going to connect it like that. And now this will run and generate more iron. So we can see here that the rock granulator is ready to run. So what I want to do here is I just want to set this to forever, which is kind of a newish feature that happened here in the last couple of updates. So now we can run this and it'll just keep, duplicants will keep running and running and running on this until it's complete. Okay, so Emily is just finishing up the last run right here. So we're at 1,950 and 50 kilograms is going to be exiting this granulator right now. So if we watch very, very slowly, we can see the automation signal is still saying this isn't full, but Emily just picked up that iron, stuck it inside there, so now it's at 2,000, and that has disabled the rock granulator. So right there we saw the example of I wanted to build up a certain amount, and then I want this machine to be disabled. Now the advantage to that, instead of actually coming down here and typing in a number, is that it will automatically refill if we go to use this. So let's say we wanted to expand this down here. We're going to add more metal tiles, and then we're also going to add something like a transit tube access point. And that requires 800 iron. So there's going to be a very big demand on the amount of iron that we're going to use. So in order to supply the need for that construction task down there, they're going to have to pull out a whole bunch of stuff from the storage bin and then start building it. But as you can see, the automation has now flipped back on over, and Fane is ready to start building it up again. So that right there is how the smart storage bin works. If we take a look at what we had here, run until X, which was 2,000 kilograms of iron. This thing is always on, and it ran until we got 2,000, and then when it's on, we turn this off. That should have a not signal on it, my bet. So here's a good opportunity to show you how this Lucidchart thing works. I'm just going to paste in a snippet right there. Fairly simple. I'll delete that, drag that into its place. Things automatically snap back into place because it's really smart like that. And there you go. I'm all done. I have made some ridiculous flowcharts in the past, and I tell you what, This is the best tool that I've ever used. Legitimately. Look at all these awesome shapes you can use, too. We got circuit diagrams, equations, Android mockups. What? Floor plans? And tables. Check that out. We can even integrate Google Docs into this thing. Super dope. Now, there's one big disadvantage to keeping this smart storage bin always on, and that can be seen in the reports. It requires 60 watts continuously. So if you take a look at the smart storage bin right there, that's negative 70. Oop, bit of a correction. What I meant to say is 36 kilojoules per cycle. That's a lot of power, especially when you consider that you may want to have one of these set up for all of your different refined metals or your different types of foods. It can add up to be a ton of power. So what you really want to do is just turn this thing on and off, maybe once a cycle or every once in a while, in order to check to see if it is full. That way, it isn't always consuming power. So that's where these two branches come in. We have PerCycle, which is just going to use a simple clock sensor, or we have PerInterval, which is going to use something like a clock that sends out a signal every 200 seconds or so. So what we're going to use to power on and off the smart part of that storage bin right there is a power shut off. And that can be activated or deactivated by an automation signal right here. And then we're going to capture the signal that comes off of that smart storage bin and then feed it back into a memory toggle switch, which either turns on or off our rock granulator. Alright, so under the power tab, you have this guy right here. This is the power shut off. We'll just click that right there. And if the power runs through that before it runs to the bin, then we can activate it just like we would a normal switch, just like this. So when you put a switch on and then you flick it off, you can kind of see how that power works. It's doing that exact same thing, but using automation. So then above that, we're going to put a clock sensor. Now a clock sensor here will send out an active sign, which is going to be green, or it can send out the red. So in this case, we really only need it to be for a duration of 1% throughout the cycle right there. And we could just detect this at the beginning or end of day or whenever you really want it to be. Let's just use the beginning of the day for the sake of it. So right now it's sending the red signal or off, and you can see that it is now disconnected. So there's no power running to that. However, if it was to be activated, you could see that it would, the power would then be on. Next to this, I'm going to put a filter gate, and then below that, I'm going to put a buffer gate. So the buffer will be for the smart storage bin, and the filter is going to be for the clock sensor right there. So then I'm going to use a memory toggle over here, and I can press O just to kind of rotate it around, and that will be hooked up just like this. So the memory toggle allows us to keep this machine on even if this thing goes off, right? So when this is off, we're not running any power to that bin, which is really important, but yet the machine is staying on. So that's the advantage there. Why is there a filter and a buffer there? Well, you can send pulses to this so quick that you could potentially cause it to be a little bit confused. So that's why they're there. It happens far less with the clock sensor, but once we use the clock pulse, these are pretty much required. All right, so we're very, very close to filling up this smart storage bin. And you can see how this cycle is going to end. Boom, we're at 2,000 right there. But it still has a off signal, right? So it hasn't told the rock granulator yet to stop running. So we have to wait until the end of the cycle or the next time that this clock sensor is going to run around in order to check that. So you will build up a little bit beyond your maximum. Okay, so at this point you're going to see the clock sensor run, and then it's going to check the status of that bin down there. And it's turned the rock granulator off because it's detected that it is full. So at this point, it's not going to run until we draw more out of that bin. Once again, we're going to build some more tiles and another transit tube access point. So we're going to pull in a whole lot from the smart storage bin, but as you can see, even though that has now gone down, we have not turned the rock granulator back on. Okay, so you can see that we made it to the end of that cycle, and we haven't replenished anything into that smart storage bin. And at the beginning of the next cycle, you can see that it's detected that, hey, you know what, I'm not full, so it turned the rock granulator back on. So that right there works pretty good if you have something that's in low demand. However, something like a refined metal, you end up using a lot of, and you don't necessarily want to wait and then, a half a cycle or whatever just to start making more of it. One of the ways that we can kind of check the system more often is to put yet another clock sensor here and just add another time where it could possibly be true. So I've added yet another clock sensor to this, and it's going to check this, halfway through the cycle. All right, so we're coming up on that moment, and you can see right there, it's now going to check it. We're not quite full yet, so it just remains on. So that's one example of just how easy it is to add yet another checkpoint throughout the cycle. However, if you wanted to check it every 10 seconds or something like that, gosh, that would be really hard to do because you would have to have a whole bunch of clock sensors. At that point, what you need is something that's going to send out that signal on a regular basis. So that's where we get into one of these clock pulse units right here. And there's many different ways to set this thing up, but this is just how I do it. So here's how this works right here. I have a buffer gate that has my interval set up, and then I use the not signal right there. So those two are just connected like that and like that. And then this will send out a pulse every 10 seconds or whatever time I type in right here. So if I wanted this to be every 3 seconds, you can see that's what that's doing. Or if I set it to 5, or in this case, maybe I want to set it to something like 60 seconds. So we just check it every minute of actual gameplay. In-game time. So per cycle, there's 600 seconds per cycle. So this will be checked 10 times throughout the cycle. And then I use a buffer gate up here in order to hold that signal for a decent amount of time. Because this flips so quick, you don't necessarily get a great pulse out of it. So that's where the buffer gate comes in. So the thing about this clock sensor is that it doesn't necessarily need to be down here next to this equipment. There's a good chance that you're going to have a couple of these set up because you want it to work for specific types of material. So at that point, what you're really going to do is set up your clock somewhere where it's convenient, and then you're going to pipe in that automation signal. So we're just going to get rid of these little guys because we don't need those anymore. And from my clock up here, that's where I'm going to connect this guy right there. All right, so here we are in cycle 45, and what I want to see here is the reports telling me that this smart storage bin is now using 600 joules instead of 36,000. So if we take a look at the reports here, what we should see is the smart storage bin down there. Yeah, it's not using much at all. Look at that, 312 joules right there. So you can see in that cycle right there, the smart storage bin only used 504 joules, which is actually less than I expected it. And if we take a look at the automation, you can see that we're currently at 2,350 of 2,500. And we will complete this pretty soon. Once they put some more in there. Okay, so now it's max, and then the clock will come around and it's going to turn this thing off. So they did make just a little bit extra, but not much. Not like the rest of the cycle. They weren't continuing to produce it. So that's the advantage of using interval. So that kind of lays out the different advantages that we have here. Always on uses a lot of power, but there's not much overrun. PerCycle has a fair bit more overrun, but it's very, very easy to set it up. Per interval kind of does the best of both worlds in that there's not much overrun, but it does use just a tad bit more power, but ultimately that's not very much at all. So running this until we have a certain amount inside that storage bin is great, and it's nice and efficient. However, we are relying on a duplicate to come on over there and sweep it up. So if we talk about the overflow, that's essentially what we have extra labor that we're tapping into. Maybe our dupes are running around and sweeping, but the thing is they might have other jobs to do. One great way to alleviate that pressure and make the system real time is to use an auto sweeper. So that thing can just sit up there and it can move things around. However, that is real time and high tech as well. We can do more of a batch manufacturing process using a weight plate down here. So what this weight plate is going to do is it will measure how much has been worked on that machine in that cycle, and it's not going to react. It'll deactivate the machine maybe once we have built up 400 kilograms of iron, and then somebody will have to sweep that away before the machine can be re-enabled. You can get much more fancy than what I'm showing right here, but let's go ahead and just see it in action. So this is what I have set up right now. I have a weight plate down here, and it's set up to be below 200 kilograms. So it'll be active if it's below 200 kilograms. Both of these need to be true. I'm using an AND gate right there. So as we can see, the weight plate is now 200 kilograms on top of it. So there's some sand and there's also some iron as well. And Emily is quite confused. She doesn't know what to do. And that's because I've disabled her ability to put things inside of storage. So if we were to just make that more normal, she's going to pick up some stuff off the plate and that will re-enable the machine so she can get back to work. So what this is doing is it's forcing her to stop every once in a while in order to clean up the work environment and take inventory of just what all she's created. This can also be achieved by having other dupes do the same process so that Emily might just stay here and continue working and they come around and cheer each other on. So I've queued up a bunch of work downstairs to use up iron ore, and one thing that's interesting is the dupes are going to pull off of this actively. So rather than going on over here to the storage bin all the time, they're going to find the closest chunk of iron ore, and they're going to pick that up. And then they're going to turn around and run back downstairs to build the next thing that needs to be built. And because of that, Monk is really not ever going to stop running on the machine, except for this one gives out sand as well, so sand can stop it as well, so you have to pick that up. Now, the cool thing about this behavior is it allows us to run an inventory system with safety stock. Now, this is a real thing. I actually set it up in my last place that I was working at right here, and that's because they wanted to know all of these different bolts that were on the machine so they could package them and deliver them to the machine. But since every single machine was different, that's just a ton of labor. So what safety stock is for something like bolts and things that you use on every single machine or something like that. It's these high volume items, or in this case, iron ore. We use iron ore on all these things. So we can set this up to where we want to build up 10,000 kilograms of iron ore, but we only want to refill that iron ore once we get it down to 1,000. So how this works in real life is you have something like a bin where you just fill it up, and then once it gets really low, then you order another 10,000 of that thing and fill it up again. And this is something that just happens on a regular timed interval, or you do something more fancy, which is back flushing, but we're not going to get into all that. How you do it inside of Oxygen Not Included is you simply have an access side. So the duplicants can only move this direction, and they're going to pick the first thing that they come across. So there's the order of load and unload. So they will load it from right to left, and they're going to unload it from right to left. So what I have here is a regular storage bin, and then to the left of that is my smart storage bin. So this behavior is going to be fill until the bins are full and refill once the storage bin is empty. So essentially this is going to be the amount of inventory that we want to track, and this is just going to be our safety margin right there. So once you fall below that safety margin, you're going to restock all of that inventory. So to do this is ultra easy. We're just going to put a storage bin right here in between the path of the duplicants and, our smart storage bin. So I'm going to set up my safety margin here to be 800 kilograms, and then the amount I want to keep on hand all the time is going to be 2,000. So I'm going to have a total of 2,800 iron when it's all said and done. Up here I'm going to put an auto sweeper, and it's just going to act as a duplicant to sweep things up for me, so I don't have to rely on the amount of time it takes for a duplicant to run around. And that also means I don't need this whole batch thing down here. That's kind of weird. I'm not sure many people are going to do that. So here is the final arrangement. You can see the automation up here. We have a clock, and then we have this unit right there. And my duplicants are just going to run this rock granulator until I fill up this storage bin, and then once this one's full, then it will turn off the rock granulator until all of this has been depleted, and that falls below 800. Okay, so you can see how this is working right now. We have the dupes, they're running on the machine, kind of loading up different things. We're building this up to about 2,000. It's also important to look at the priorities here. These are the same. I have them set to 4, but they can, as long as they're the same number, it'll go to the closest first. Hopefully, unless the game's giving you a hard time. So that's 2,000 right there. In the next cycle, we're going to start to build this up to 800. Okay, so we're just about to the end of restocking here. We're up to 750 kilograms, and now it's full. So the next pulse that'll come through disables the rock granulator. So you can see now we have 2,850 iron. We made one extra, not a big deal. So we can build a couple of these things, but that's going to demand a whole lot of iron. So you can see that the duplicants are going to pull out of this storage bin right there. And we've already sucked down our 2,000, and now we're below our 800 kilograms as well. So on the next pulse here, you can see that that will re-enable the rock granulator to start running. However, let's say that we only built 2 of those transit tube access points. Well, you know, let's run one more test. We're going to make another transit tube access point here, but we're not going to pull it down beneath the smart storage level right there. So we've grabbed about 800 kilograms out of here, and then we're going to deliver it down there. And you can see that that doesn't re-enable the rock granulator. So there you have it. Safety stock inside of oxygen not included. Pretty cool. So there you guys have it. From a comment to an idea, which is running until X, and we even went as far as to do batch and or safety stock craziness stuff down there as well. Pretty dense there at the end. I do realize that, but this is going to be available for you down in the description below. You can go ahead and download that. If you're interested in flowcharts, maybe check this one out right there. That link in the description and or here will help support the channel. Thank you guys so much for that. And overall, I'm quite curious what you guys think about this new format for tutorials right here. I think it's a pretty cool system. I think it's a way for me to update certain things after I create the video in case something changes. And it's also a great way to link to certain videos and whatnot. I think that's going to be super helpful. So if you got some other ideas for other tutorials, go ahead and leave them down there in the comment section below. Let me know what you thought about this one, guys. If I've earned your subscription, then thank you so much for that. Have a great day, guys. Stay awesome. Peace. Brothgar.